This video is going to be a code review. I hope you get something out of it. Essentially is just an exercise, right? It's just another chef in the kitchen cooking a steak, maybe a little bit different than the other chefs. I'm going to approach a data set that is, let me see here. I can't remember the name of it. It was melanoma. So let's type in, oh, there it is, melanoma cancer image data set. So we're on Kaggle, by the way, if I didn't mention that before. Now, this top one is the one we're after. So you're after the icon, this picture, if you want to follow along, that is. So the code section is what we're going to go after. But first, let's talk a little bit about what is outlined here. Usability of the data set is 8.75. Means it's a little bit more difficult to use. The description, context, and source inspiration, stuff like that, background, is all listed here at the top. And that's important stuff to know. Very important stuff to know. So you get a background on what's going on. Then down here, you can actually look through the data set a little bit. Now, if this is just a normal data set, then there will be data setting in here, but we're actually working in a directory of pictures. So what you'll see is you can look at the pictures, and in here you can get a feel for what those pictures look like and what you're going to be trying to train your solution on. Now, under the code is my code, which I've called computer vision without a neural network. Now, by the time this shows up, I might have several out here because I have a suspicion in this data, and I'll go through that at the end of this video. But first, let's just review the solution that I built out here. What I'm trying to do is build out a solution without using a neural network. So neural networks in this case is the de facto go-to. But I want to prove that you don't necessarily have to go to neural network. And in fact, the exercise of going without the neural network actually can benefit you because you're going to learn a whole lot more about the data. So data sample, I took 100 of each, which the data is divided into train, test, and malignant and benign. Okay, so there's 4 groups of data sets. So I took 100 out of each one. This isn't really following the competition rules. I'm really not participating in the competition, although I have a notebook in here. But we're looking at like, okay, here's 400 imported. We're going to go through business intelligence, look at the different features of the images, because that's extremely important. And a lot of people skip that step. They just go right into trying to classify, going into the algorithms and such. But we're going to find some stuff that's going to be quite interesting. And then classification. We're going to use just random forest, KNN, and XGBoost. Now, it is very important to note that in the use of medical data, you don't want to have any false negatives if you can help it. So we'll go over maybe how to approach that with just these solutions in here. But it's very important to note that when you're dealing with medical or something that is absolutely critical that you're getting right, you're going to go ahead and sacrifice accuracy for 0 false negatives, okay? We're going to import these packages, and we're going to trust but verify. So this is where we're going to start looking at a little bit of information about our data. So this is just importing the data, bringing it into a data frame so that we can start to look at it. And now we want to understand, all right, among the data set, how split are we? So we do see that in the train benign side, we do have more than the malignant train side. The test side is both even. So this can potentially, depending on the features in the pictures, create an unintended bias if the train benign has features that are prevalent that are not in the malignant data sets. So we need to be very careful about that. We may need to resize these data sets to make sure that we're getting a totally good data sample, right? Not sample, but you get the point, right? These need to be even. There you go. All right, histogram of the size of the images. Size of image and the ability to extract detail out of the pictures is going to be very important. So when you have images that are really low resolution, you may want to drop them. just go ahead and get rid of them. When they're really, really high resolution and most of your pictures aren't, you may want to drop these too. So this is just histogram of size by, I don't know how many bins. I put 30 bins. So you get it's normal, well, somewhat normal distribution, skewing to the left. All right. Anyways, you get a point. We looked at the data. We understand now what's available in that data. And what we're going to do is move on. All right. We're going to import some images and just take a look at them. Down here, you see what those look like. Now we can use the Kaggle viewer to look at them as well. I just brought in these samples so I could take a good look at them. All right. Ooh, gross. Yes, it is. Medical stuff is ooh, gross if you're not in the medical field. All right. We want to pull the image data in and create some information from that. We're only going to pull 400 in. Image data takes a long time to process, and so 400 is good. 400 is great, especially if it's a random sample. All right, dominant color extraction. We're going to take the top 3 dominant colors from every record and compare them. The output gets graphed. You'll see here that there is a pretty significant difference. So you have the benign, malignant. This is a 3-dimensional graph. The larger the circle, the closer it is to you. The smaller the circle, the further away. And then you have your scale of color. This is RGB. And what we do after that is look at the p-value, f value of malignant benign to make sure that we are, in fact, what we're visually seeing here is statistically correct. Like we are seeing there is a difference in these populations, right? There's a difference there. And the values actually validate that. Contrast. So we're going to look at contrast. And we see that benign and malignant are, tongue twister, are again different. Okay, so when we talk about contrast and color, we see some difference in the population. Now let's look at texture. Texture, not so different. It's to the left, but they're overlapping enough to where maybe possibly, and actually the p-value agrees with that. All right. There's potential here. That's what this guy's saying. There's potential. Let's create a consolidated data set. Basically, we're redoing what we did above or scavenging from what we've done above, and we're creating a data set that has RGB 1, 2, and 3, contrast, texture, and then whether it's malignant or not. We don't want a column for both malignant and benign because that is redundant. We just have one value. We know the other one was true. All right, we're gonna force. Now when these pivot in, these RGBs, they come in as text, so we're gonna go ahead and put them to float. Everything's cool here. Now let's put a random forest classifier on top of it. What we're gonna do with the random forest, we're gonna ask it to do cross-validation 5 times on each combination of this grid search. Now, I already have tuned this, took a look at it, ran it several times with different parameters in here. You're welcome to go in here and go to the edit section or import notebook, whatever it gives you on your side, and play with this. And you'll probably find that I think I got it. I think I got the best that it can do with this particular sample. And what we find is the recall is very high. The precision is very high. And when we go down here and look at the false positives, it's low. It's great. It's good stuff. And really, in all actuality, this is a pretty good go. And when we look at the ROC curve, we find that it's 0.84, which is actually really super good. If we wanted to take and get ourselves into a higher degree of or fewer false negatives, then we would just slide over on our scale here. It doesn't look like we ever really, well, we could hit 100, but we lose accuracy in the other areas. So here, this is a really good indicator right here when we're getting a really good score at the 0.5 mark. This is great. This is wonderful. I know I'm stuttering over this, but you get the point. It's good stuff. It looks good. Don't know how much of this to actually explain. I'm tempted to go in depth, but I don't know the audience. So if you're more interested in ROC curves, just look it up. There is some really good videos out there about it, along with the confusion matrix here, as well as the interpretation of the scoring here. All right, let's go to the next one. KNN classifier. This one, again, we're going to use a 5-time cross-validation, so CV equal 5. And then in our grid search, we're only going to select these. We're going to let it go through, figure out what it wants to use. Again, I've already gone through this. These are the good ones. And what we'll find is that it, in fact, is getting an 80, 79, and fairly good, right? And then ROC curve, fairly good. So 79. Overall, though, what you find, the random forest did do a better job. And we go in and look at the XGBoost. XGBoost got 3rd place because over several runs, now you'll see in this case, it actually did better than, we got 0.8. When you go up here, you got 0.79. Over several runs, the XGBoost continuously scored the lowest. Now, XGBoost usually does a really, really super good job. In this case, not so much, but that's all to do with what data it has to play with. So if we created some other data features, maybe it would do better. That's pretty much the end of it. This is, again, just another take on how you might cook that steak. Again, we're all chefs in the kitchen. It's a pretty good exercise overall to learn how to extract information from images and use that then subsequently to analyze what's going on with these pictures. Before I do any neural net, I would be doing this. I would be trying to find what's the difference in the pictures. Now, let's get to what I am hypothesizing is wrong with this data. And this backs up. If you go through the images and start scanning them, you're going to find that the malignants often have this circle. And I have yet to find a benign that has that circle. So I am going to create an extra notebook, another notebook, and try and get a solid count by malignant and benign, that circle. Try and figure out if there is accidentally a bias in this data set. And then what you can do is essentially cut the pictures out as a circle, every one of them. That way that every picture looks the same. It's all, the focus of the image or the theme of the image on a black circled background. That would get rid of the problem, essentially, if there is a bias in it. All right. Look for the next notebook. Thanks for watching. Have a super good day. Bye-bye.